Our speaker this evening is a PostgreSQL developer at 2ndQuadrant, as well as a member of the PostgreSQL Global Development Core team, meaning he's part of the guys who actually make Postgres. Please welcome Peter Sanchez.
Hi, I'm one of the ones from Pennsylvania. So I took the train up here. So, hi, and this very knowledgeable audience here. Some of them really, I was under the impression the trivia would be after the presentation to kind of make sure you guys pay attention, but a lot of you guys already knew all that. So, yeah, I'm Peter Eisentraut. I work with 2ndQuadrant. I'll explain what that is in a moment. I got some brochures that a lot of you picked that up if you want to know what we do. So I'm going to talk about scaling out PostgreSQL tonight. How many of you, I know this is sort of a general database user group, how many of you have used PostgreSQL already? Okay, so 2/3, good. And how many of you came through the PostgreSQL user group? Ah, cool, good. It's good that we posted it there too. Okay. So for those who, let's see if this works. For those of you who are sort of not really Postgres users yet, let's just kind of do a quick introduction. What is PostgreSQL? It's an open source database management system that follows the SQL standard. That's basically what we do, and that's what users want us for. There's lots of functionality and NoSQL, this and that. This is basically what we do, and that defines our core mission. So this is, some of you already knew the dates. This is sort of the project timeline. The original, the Postgres capitalized project came out of University of California, Berkeley. It was started around 1986. In 1995, the project was sort of abandoned, the research had sort of finished, and a couple of graduate students took the code and converted it to SQL. It used a different query language before that, and they converted it to SQL. And that's sort of their master's thesis, I believe. And as it was the fashion of the time, they called it Postgres 95, and then sort of left off to do other things. I believe they ended up at Informix and IBM later on. And then, so the code was just lingering, and in 1996, someone or a couple of people who were involved earlier kind of put it on the internet and say, let's sort of do open source project and see what we can do with this. And that was in 1996, and that's sort of, we consider that the founding year. And we had sort of birthday parties this year for the 20th anniversary. In 1997, we had a first release, which the release numbering is slightly confusing, perhaps, if you analyze it. The University Postgres project ran through version 4.2, and then Postgres 95 was considered version 5, and then the open source project started at version 6.0, and then the version numbers counted up 6.1, 6.2, 6.3, 6.4, 6.5, 7.0. And so all of these are kind of major releases, really. The reason for the change between 6 and 7 and 8 and 9 is sort of marketing, really, doesn't really have any technical reasons. And as many of you knew correctly, the latest major release is 9.6, which was released actually just 2 weeks ago. And we do major releases now about once a year, so next year's release, we're actually going to change the way the versions are numbered, because we kind of got sick of this argument of whether it should be called 9 or 10 or what. So we're just going to go with one number now. So the next release is going to be 10, and then it's going to be 11, 12. So that's a new thing we're going to do start next year. So releases are usually in September. So next Postgres 10, if all goes well, it should sort of a year from now we're going to have Postgres 10. And later on, I'm going to kind of talk what some of our plans are for that. So who is PostgreSQL? It's an open source project. It's not run by a single company. So you can compare it, similar to maybe how Linux kernel not owned by any particular companies. There are many companies contributing to it, or a Python project, for example. There's not a single company that sort of develops it internally and just kind of open sources it. So who is PostgreSQL? It's basically all the volunteers that just show up on a mailing list, can do something. A lot of them do code, obviously, but there could be others, such as people in the back there who run user groups, or work on a website, or just do conferences, or even like events like this. So, and there's no sort of definition of who's a member or anything. Just if you show up, contribute, and people recognize quality in your work, then you're part of the project, really. So the sort of the inner circle, in a way, is the committers. Those are the people who have the right to commit code directly to the Git repository. So they're sort of the guardians of the code. And we have about 20 of those. And then the official representation, if you want, is as official as it gets for an unorganized project, really. It's the core team that was mentioned earlier, that are 6 people, 3 of which happen to live in Pennsylvania. And actually, a 4th person also lives in Pennsylvania who kind of retired from the core team. So I don't know what's going on in Pennsylvania. But so that's, and there's 1 person in California, and then 2 in Europe. So that's sort of the steering committee, or the leadership, or if someone needs to actually contact the project, that you could contact the core team. But in reality, it doesn't do much. So I'm a member of that. And I'm also a committer. So the other side of PostgreSQL is the commercial side. There's not a single company that kind of owns it or runs it. There's many companies that somehow interact with the project. A lot of companies just do consulting or use it somehow and help people use it somehow, sell services. Or some of those companies you might recognize. I just grabbed like a whole list from the website. And for example, Heroku does hosting, and then some people offer like a forked or extended version of Postgres. And so all these companies somehow have chosen to have some kind of business model around Postgres, and they all work together and against each other in trying to make some money, competing against each other, but also trying to enhance the product together. So it's kind of interesting. So I work for a company called 2ndQuadrant, and it's been around for more than 10 years, and we sell services for Postgres. And that's consulting, support, we do development, and those kinds of things. And we don't really have an office. We have people around the world, mostly working out of their homes. And so we have people in all kinds of different time zones, which is kind of good if we're offering 24/7 support. You always have someone who is awake locally. You don't ever wake anybody up. That's nice. We do think that we are one of the leading companies who actually contribute code to Postgres. So some companies use Postgres or offer services around Postgres, but don't necessarily contribute much code. So we make a point of dedicating people, such as myself, to actually write code for Postgres. Like that's sort of partially my job. That I just have a project, I write code for Postgres. So that's what we do. Just aim for the computer behind the screen here. So today's talk is about scaling, which leads to replication. So I want to kind of give a sort of a timeline of what we've done so far and what we want to do. So I kind of want to give sort of a lot of sort of years and timelines of how things happen and when things happen. So as I mentioned, the first open source release was 1997, and sort of the first couple of years really was like there was university code that was not really production ready. It was interesting, it did interesting things, but it was not really something that you can just deploy and it works and is robust. of sort of research stuff in there, and weird attempts to do certain things, and so the first couple of years was really spent of cleaning stuff up, fixing bugs, ripping stuff out that is not going anywhere, and things like that. So this is sort of my retrospective of, this is not an official sort of tags of these releases, it's just sort of my interpretation of these eras of what happened. I got involved around 1999, so I let other people do the fix work, and then I just got into the glory years. So the 7.x era was sort of the time when it actually started working. You could really use it reliably for things, I think. And then around 8.0, it was really sort of getting real, and a lot of people got involved, and a lot of interesting advanced features were getting developed, such as point-time recovery, window functions, and advanced SQL functions, and really a lot of good performance tuning was done. So people were really investing in it at the time. And 9.0 is when, which we'll get in more detail, is when replication really started happening. And it's perhaps the version change from 8.4 to 9.0 was kind of chosen to reflect that this is sort of now we can actually do proper replication, and then so let's give it a new major version number. And then sort of looking forward, we think hopefully the next few years are going to be the era when we can do logical replication and do fun things based on that. So people needed replication quite early on because they had everything was on one box, and that was kind of scary if that box goes down. So people started thinking really early on, it's like, okay, we got to get it off here somehow. And then people said, I know how to do that. I'm going to write a trigger. And you can write this in, you can code it up in 10 minutes, and you can finish this in a day. It's like, okay, I'm just going to have tables, and then I'm going to just, write a trigger for the table that says, after I insert or update or delete something in that table, I'm going to store each row in a log table somewhere. And then I'm going to have another daemon somehow that takes stuff from the log table and sticks it into another host and inserts it there. And that works. It looks simple, but it's a lot of work to actually get all the details right. If you have to remember how far you got, then what if you crash? You need to know where you can pick up again, and what if you have multiple, and what if you want to change the configuration to switch master and slave? So you can do this, and people have done this, but the details are really hard. But that's sort of what the first thing that people did. And there were some quite popular products in 10 years ago or so now that implemented that. The very first attempt was actually shipped in the Postgres source code. I kind of just dug that out the other day. I didn't actually realize that was shipped for a while. Something called rserve that kind of did a very basic version of that you had a trigger that collected the data in the log table, and then you can sort of ship it off. Very popular project was Slony, and all of these have to have names that are hard to remember, of course. So, very popular project was Slony, which was developed by a company called Ophelia. So these are all open source, but the company called Ophelia, who runs the domain registry for initially .org and .info, and now a bunch of these other domains too. And so they developed that for their use because they had to replicate stuff around for their uses. So they said, like, we really need some replication that's just better than all these like handcrafted things. So they put some resources into that and developed that. And that was quite popular for a long time. But then people thought, like, Slony is too complicated and hard to manage, so we're going to develop another one. One result of that was Londiste, which was built by Skype, which also runs on Postgres, so they needed something to replicate, and they thought that it's better to go and then use the complicated previous version for whatever reason. And that's still quite popular. And then another one was Bucardo, which does kind of similar in functionality, but the implementation is completely different. That is another alternative. So if you no different languages. The reason these are called that way, Sloanian is based on Russian, and Londiste is Estonian. That's what the developers were from. And Bucardo is apparently some kind of animal that was cloned at some point, so they kind of picked that name. So, but these things work, and at the time that was the only thing people had, so that's what you did. But they had lots of problems. So first thing is you need to have a separate piece of software that runs it. Okay, that's okay with packaging and stuff, so people kind of got used to that. That was okay. Schema management are very difficult because every table has a trigger on it. So if you need to change anything about a table, add another table, do anything like that, you have to update all these triggers and things like that, so that's very difficult. Adding triggers or changing triggers or anything like that needs a table lock. So every time you need to change something, you really got to lock everything down. That was very difficult for if you just need everything online all the time. The other big problem for performance and scaling really is if you have a trigger that hooks into changes in a table and writes it to another table, you have doubled your write volume. So if you think, okay, I have one machine that is really running out of resources and I need to scale to more machines, the first thing you need to do is you have to double your write volume on that first machine, right? So that is really not a good strategy. So it requires really planning ahead before the machine is exhausted. So that's a big problem. And managing that lock table itself is difficult because you need to purge it all the time and get that free space managed. And if you know Postgres in a little bit, you know that kind of thing is difficult because of the way the storage manager works. You would need to vacuum that all the time, and that's just a big mess if you're really running this at scale. And just the general management and monitoring and doing all this it was quite difficult, especially with Sloanie. I was just talking to a colleague the other day who said, like, oh, I have some experience with doing Sloanie and this and that, and repairing Sloanie, and I just sort of joked, the way to repair Sloanie is you just rip it out and set it up again, because it's just really difficult to understand what is going on. So people use that, but it was not really what we wanted. So you really needed a built-in proper replication system. And if this were a product company, we would just sit down in a room and say, okay guys, we need replication, how do we do it? And then we would come up with ideas, and somebody would decide we're going to do this, and then you go back to your desk and start typing, right? But this is not how Postgres works. And especially in those days, nowadays you could arguably do that because we have some companies with dedicated developers and they could kind of work that out, but back then it was mostly volunteers that sort of did it with, in the evenings or as sort of part-time occupation or things like that. So it was difficult to just tell someone, okay, we gotta do some replication, let's figure it out. And so what really happened is this sort of trickled in accidentally. I like this timeline because this is kind of a weird history of how code came about. So the way physical replication in Postgres, and this is what people are using now, right? This is the code that's been around for a while. The way this came about is just sort of piece by piece. So in 7.1, we implemented something called WAL, the write ahead log, which is a sort of standard feature that you also know in file systems, sometimes called a journal. So every time you make a change, you write it to a journal, and then you also write it to the actual system. And if there's a crash, you replay the journal. So this is basically a performance feature, so you only have to sync the journal to disk, you don't have to sync everything to disk. So this is basically a performance feature at the time. And then in 8.0, and this is actually something that people from 2ndQuadrant at the time already developed, was we implemented point-in-time recovery based on the write-ahead log. So what you can do instead of, initially the write-ahead log was just an internal thing that you couldn't really do anything with. But the point-in-time recovery feature took that and said, okay, we can also save the write-ahead log somewhere else. And if we ever need to roll back, we can take that write-ahead log and replay it to a certain time, hence point-in-time recovery. So that was a good sort of one of those like enterprisey features that some people wanted. It's quite complicated and not everybody really uses it, but some people really needed that to roll back to a certain specific time for sort of analytics or some kind of auditing or something like that. So that was implemented. And then some people said like, well, I can also take the archived write-ahead log and instead of sort of recovering on the same host, I can also recover on another host continuously. So as it is written, I recover on another host at the same time. And then you have a copy, right? You can constantly update a copy. And so people played with that a little bit, and you could sort of script that and hack it up a little bit yourself, and that worked for some people. And then in 8.3, somebody wrote a program, a simple program that kind of helped you do that. So a lot of people sort of liked 8.3 was sort of the threshold for some people where you could kind of set up a copies fairly easily. So in case, just so your primary copy totally dies for hardware failure or something like that, you have a copy somewhere that's pretty continuously updated. So that was already very helpful. It doesn't really help you with scaling because it's just a copy that is recovering, but you can't access it. Only when you fail over, you can then bring it out of recovery and use it as your normal database, but it's not a read-only copy or anything like that. So that was the big threshold in 9.0, and that was mentioned earlier, the hard standby feature, which also a colleague of mine developed, was enabled that while the copy is recovering, you can actually connect to it and run queries against it. And that was a big thing, because now you can add a bunch of these, and as we said, you can add as many as you want. And that helped people a lot with all kinds of applications. For scaling, you can add many copies. For rescaling, you can have copies for analytics, or you just have a copy for disaster recovery. So that's the hard standby feature. And at the same time, totally independently of that, was developed the streaming replication, which instead of copying archives around, the standby connects to the master directly. That makes the management much easier. So the reason I can't put a smiley in there, that was sort of the threshold of now we actually have replication. Right? Before that, we were kind of embarrassed or making excuses or said you can use Slony. And at 9.0, we could really say like, Postgres has replication, please go use it. And then it really took off. People said, oh, we have replication now. Okay, cool. It's kind of, it works, but it's kind of hard to manage, so let's put all these other things on it. So, and then so every release, as I mentioned, this is sort of every year, there's new things coming on. People said, okay, the base backup needs to be done easier, so we wrote a program for that. How about synchronous replication? So instead of just asynchronous, synchronous means when you commit, the commit does not finish until it's written over there. Very important to some people. Slower, but important for data availability for some people. So do that. Cascading replication, so you can hang a slave of another slave, and then standby follows timeline switch, which nobody understood at the time what that means, but it actually means if you have one master and two slaves, the master dies, so this becomes the new master, but then this guy is still pointing to that guy. You can just point it to this guy now. That's what that means. Before that, you couldn't do that, so you have to rebuild it. So you fill in all these gaps over time. In 9.4, we released something called logical decoding, which people thought like, oh, this is logical replication, cool. Like, no, it's not. Okay, so this is just one of the building blocks, and I'll put that in the context later. And replication slots, which again, nobody understood because it's, okay, what does that mean? That just basically helps you register slaves, so the master actually keeps track of the slave. So when the slave dies, the master actually knows, oh, there's a slave, I have to hold on to this information when the slave comes back. Before that, the slave disappears, there's no record of it. Instead, you have to rebuild it. So that helps. These are also the pieces, right? It's hard to know. It takes a lot of knowledge and experience to actually know how these things fit together. 9.5, another tool was added that helps you, if you fail over, that you can fail back, which otherwise wouldn't be possible. And now 9.6, which was just released, is sort of, it gets sort of more esoteric over time, right? You can have synchronous replication with multiple standbys, so the commit is not acknowledged unless it's written to multiple places. So, there's more work, and I know people are working on other variants of this now that you can have sort of various complicated definitions of quorums for synchronous replication and things like that. That's something that people are working on. But basically now you're at a point where built-in physical replication really works. So this is kind of how it works. I kind of illustrated it already. Master database writes these wall records, which are 16 megabyte files on disk, essentially. So and what you had to do initially is you kind of had to get them over yourself. You had to write some kind of script. And popular choices were scopy rsync, or you just had to share the NFS device, and then you kind of write some scripts to make sure it gets there, and you have to exchange keys and all that terrible stuff. And so that's how it kind of worked initially, but then with streaming replication, streaming application actually told this guy, just connect here and get the stuff, which makes it much easier to manage. And that's basically what most people use nowadays. So how does it work? A lot of you will know this. Just kind of put it into context for what I'll put later on. You have to set up all these obscure configuration settings. Again, the reason for this is nobody actually sat down and said, let's build a replication system that's really cool and easy to use. Instead, it was all these different pieces that were put together, and all these settings reflect one of these pieces, right? And so you have to configure a wall level to do certain things, and you have to give it, you have to reserve slots, connection slots for these things, and you have to turn hot standby on, because remember, initially this was just a recovery feature for point-in-time recovery. And they said, okay, well, if you actually want to use it as a replication slave, you have to turn that on separately and things like that. So you have to kind of do something like that. And then you have to create a replication slot. And then you have to run your base backup with all these different options. And you have to remember to put them all in there. And then you have to write a recovery.conf. Why do you have to write a recovery.conf? Well, again, it's actually kind of a recovery feature initially. And it was never actually renamed. You could say, okay, well, we could rename that to replication.conf, but it wasn't actually done that way. So it still has like all these old namings, and then you have to put all these things in there.
Could you spend 1 minute tell us what a replication slot is? I've kind of heard it, right?
Replication slot
cool.
is a way to register a slave, basically. That's a better way to put it.
You're gonna have multiple slaves.
So normally, if the slave connects to the master, it just says, give me wall record 55, and it says, okay, give me 56, give me 57. And then if the slave were to just disconnect for some reason, then maybe there's a network problem, and then it comes back half an hour later and says, okay, I want to have 50, whatever, 7, where we are, 57. And the master might have already cleared that all away because it needs to manage its own disk space instead. Oh, sorry, I don't have 58 anymore, it's all gone. And then the slave is disconnected, you have to rebuild it with a new base backup. So what replication slots allow you to do is you register the slave essentially, you make a slot, connect to that slot. That's just a piece of information you pass on in the protocol. And then the master knows, okay, here's a guy that was asking me for 57, and I'm just going to hold all this information here until he comes back and asks for 58. So if he never comes back and asks for that, then the disk on the master runs full, so that you have to manage that also carefully.
So the master has metadata about
exactly,
the slaves
right.
that are collecting to him and against
exactly.
something important.
And this was, this was kind of implemented as part of the logical decoding, and I'll put that into context in a moment. So this kind of became useful accidentally for physical application, but for logical application it's much more important because depending on what you do, there might not be a way to actually do a new base backup. if you actually don't have a full copy or something like that. So it's really more important for logical, but it's also very useful for physical application. And then if you want to switch over, there's a pgctl promote command. You have to put that in. What we did is wrote a tool called Rep Manager, which kind of makes that all sort of easier and kind of gives you a uniform interface to all these different things. So you don't need to remember, okay, I have a recovery here and a base backup there and a setting this and setting that. So this is a tool that it's an open source tool that it was or is continues to be developed by 2ndQuadrant, but it's open source, so everybody can use it. It's not very difficult. It's meant to be easy, so everyone we suggest everyone can download that and try it out if they want to manage the replication. So you write a configuration file, give your node a name, a number, and some connection parameters. That's all you have to do, and then you can just run commands like this: rep manager master register, sets up a master. You want to set up a slave, you run rep manager standby clone, sort it up, register it. That gives you sort of a uniform interface behind all these weird things in the background. Promote a slave, you just promote it, and it does all the right things in the background. There's other interesting commands. So if you want to, if you change your master, you want to have the other slave follow the new master, you have a follow command. And if you want to do that by hand, it's very difficult to change all the configuration files to point to a different place. You have to change the recovery.conf. This guy, there's some timeline stuff involved that I don't even want to talk about. So this helps you do that, and you can also do a controlled switchover. So not a failover. We say failover is if the master has failed, you just want to promote a new standby to a master. But if you want to do controlled switchover, just maybe you want to take a node down for maintenance. Switchover helps you do all that correctly. It makes sure it doesn't shut the one node down before everything's synced over. So it does all that. It has all this sort of detailed knowledge to do that. There's an additional daemon you can run, rep manager d, that does the monitoring, collects lag information that you can hook into your monitoring system. And it can also, if you want to do that, and it's a little bit of debate, if you want to do that, if you want to have the system fully hands-off and want to trigger failovers automatically, if one node disappears, it can automatically trigger a failover. So here's these pictures don't really show up here now, but there's another interesting thing is something called a witness server, and the reason for that is if you have, say, multiple data centers. And so you have one data center here with a master and maybe one standby, and a data center with a couple other standbys, and then if the network between them gets disconnected, the classic network split, you have to kind of decide what to do if you want to do the automatic failover management. And the witness server is sort of the tiebreaker on that. It sort of whatever you put the witness server maybe in another data center or connected to both places, and then whatever the witness sees, it decides who wins. So this is an additional safety mechanism to handle these network split situations. So that basically handles all these situations. So that's a repmanager.org if you want to use that. Packages are available for usual operating system. So that's quite nice and makes things simpler. So physical application, and we used to just call it replication, but now we have different things. So we call it physical application because it just takes bit by bit, byte by byte copies. So that's great for if you want to have sort of high availability. So if one host dies, you have another one standby with an exact copy, you bring that up, things continue. With synchronous replication, you make sure it doesn't lose any data, so it's great for that. If you want to do read scaling, it's good for that. Hook up a bunch of standbys that get up-to-date copies, and you can point your application to that, and you can read. You can't write, of course, but you can read. So that works for a lot of people. And the management detail is a little bit difficult, but there's some tooling and there's other options besides Web Manager, and people have written their own. But it's okay. There's a lot of knowledge out there, so it's okay to manage. And one thing that is a big advantage over things like Slonia and Londiste that we saw earlier is that DDL, meaning schema changes, are just supported without any additional problems, because every byte by byte copy, so if you create a new table, the table pops up at the other end. No problem with that. So that's what we have now. But users being users, they always want more. And so there are a lot of interesting, important use cases that don't work with that application. So, and they all kind of fall out of this behavior that you just copy the bits and bytes over without any interpretation. So one issue is you can only copy everything. There's no way you can say, oh, I just want to copy this one table, or replicate this one table, or replicate this one database, or anything like that. It's not possible. You just get a complete copy of the instance. So you can't have multi-master replication because you can only copy the bytes that way, and you can't copy the bytes back. It doesn't work. It's just not possible in that architecture. There are some issues that bother some people with temporary tables. So temporary tables on the master are not replicated because they're just kind of kept in memory. They're not in the wall stream, so that's okay. But you can't have temporary tables on the standbys either, because the temporary tables need to be registered in the system catalog, which would be a write, and you can't write. So you can't have temporary tables on physical application standbys. And people have tried to work around with that, and it bothers certain applications that make use of temporary tables. Especially people who use a lot of stored procedures like to use temporary tables as temporary storage. It doesn't work, so that is bad for those people. There are some complications that arise out of the way that space is cleaned up. So if you have on the master vacuum process, or any kind of process really that cleans up old stuff, that change information is shipped in the right headlock over to the standbys, and it's cleaned up there. But if you have some long-running queries, maybe you're doing analytics, you have a long-running query on the standby, and at the same time there's a change record coming in saying clean all this stuff up, you have to make a decision. You let the query run, that might be a legitimate choice, but then the change to clean up cannot be applied, so that's held back. Or you cancel the query, but then you can't run the query. So you have to make this trade-off, and that kind of creates this, for some application, this strong coupling between all these nodes, because this node cannot do its cleanup when the other node still is running queries. That, in some cases, needs very delicate tuning. You can't do replication between different major versions because it's just the bits and the bytes, and the bits and the bytes look different in different major versions, so you can't do that. And some people also want to replicate to other databases or other applications, not necessarily just from one database to another, but you maybe just want to do, replicate into some kind of different analytics software or a different database system that is for analytics maybe, or you want to do change tracking where instead of just really replicating and writing everything into a database, you just want to see what's going on. You want to have a record of changes maybe for auditing or some things like that. So you can't do that with this system. So people are thinking about, yeah, we need some what we now call logical replication. So not just copying the bits and the bytes, but actually interpreting what the changes are and then presenting the changes in a way that different consumers can process. And so people at 2ndQuadrant and others, but mainly led by 2ndQuadrant, they got some funding from customers and some research grants, and decided we're gonna do this. And so whereas physical replication was kind of a sort of bottom-up approach, this was more of a top-down approach where people actually sat down and said, okay, how are we gonna do this? Let's think how we're gonna do this, and let's implement something. And so the first result of that effort is the BDR project, BDR for bi-directional replication. And so that's a project that you can get at that URL. That implements Multimaster logical replication of PostgreSQL. And so the way this was developed is it was based on whatever the Postgres version was at the time, which sort of turned out to be 9.4 beta. And then it was just built as a fork of that. Was a patched version of that. I don't know what you want to call it. And so you can use this now. It's still based on, it's still the same, basically based on 9.4. So you use the patched version of 9.4 plus a plugin, and then you can replicate away. You can have multiple nodes. I'll show how that works. And then you can write to multiple nodes, and they all talk to each other. And there's also sort of a sort of degraded version of that. If you just use the unpatched Postgres plus the plugin, you can use what we call unidirectional replication. So that's sort of a degraded replication system that we're not really promoting, but you can do it. You can have basically a logical application system with only one master. So,
is this project still under active development?
Yeah, I'll explain where this is going. Yeah, well, this is still being worked on, yes. So this is kind of the marketing picture for that, and the main use case we think for that is if you have multiple distributed locations, multiple data centers, you can hook them up, and you can write to whatever is closest you can write to, and then they all sync to each other. And then if you can't really see this picture, one issue that was mentioned earlier during the trivia is that the way it is currently done is that all nodes are connected to all nodes. So this one has an error to this one, to this one, this one. This one has an error to this one, and so on. So all of these are connected directly. And so because of the way this, the number of connections explode, it's currently capped at 48 nodes, which is, a reasonably high number. So, but if you want to grow beyond that, you would have to have some kind of alternative way of managing these connections, so not everyone has to talk to everyone. But that's
48 is a good number, right? Rack only is like 4 or 6 or something.
Yeah,
pretty good number.
48 is a lot bigger than 4 or 6. Right?
Yeah, even 4 or 8.
So these are some of the features that had to be implemented as part of that. So these are features that went into this fork. So the first thing, we needed the first sort of major decision really on how to do this was how are we actually going to collect this change information. And the choice was made, and it's sort of a difficult choice, but the choice was made that we're not going to collect a second log of changes. We're going to take the existing write-ahead log and then have a logical decoding of that. So first we're going to write the binary changes, and then we're going to have another process sort of in the middle that takes these changes and decodes it into logical change information. And this kind of sounds maybe more complicated than it should be, and it is quite complicated. But the reason why it was done this way is for 2 reasons really. One is you only want to have one log for performance reasons. Otherwise you have to maintain multiple logs. That means double the write volume. And the other reason is basically the core code doesn't have to be touched in every place. Because right now, the way the code is structured, every time you write to disk, you have to make the wall record for that, right? You the wall record, and then you write your actual file to disk. And then you would, if you were to have an additional logical log of some kind, you would have to do, every piece of code has to be touched again. So that is very hard to maintain. So the decision was made that we'll have logical decoding. That was a feature of 9.4 that allowed you to not have logical replication, but it allows you to write a plugin that takes the logical change information and do something with it. And what BDR and others have done is write that plugin, basically. So, but there's other things that need to be done. For example, one thing that had to be written was a facility for additional background workers. The way Postgres works is you have one process for each connection, and that's basically it. But if you want to have replication, you need additional processes that connect to the other nodes and process information and write it down and stuff like that. So you need additional facilities to manage all these extra workers that had to be implemented. Origin tracking, it gets more esoteric here perhaps, but origin tracking is if you have bidirectional replication, you need to somehow record where the change came from so you don't send it and then you send it back. So you need to know where it started so you can stop it somewhere. And commit timestamp, you record the timestamp for every commit. Why do you need that? Well, normally you don't need that, but for conflict resolution, you might want to know which came first. So if you want to know the first one wins or the last one wins, you need to know what the time was. So that had to be implemented. Event triggers had to be implemented so that you can replicate schema changes. So you write a trigger on a create event, and then you send it around or manage it somehow. So that had to be done. And then you have to do something about sequences. And sequences is very tricky in a replicated environment because sequences are not transactional. You can get a number from a sequence, but if you roll back the transaction, the number is not rolled back. And that's intentional for performance, so you can get new numbers quickly and you don't really care about the gaps. But if you want to replicate this, this kind of makes it difficult because you can have, they don't really observe transaction boundaries. Because normally you want to replicate committed transactions, but these things kind of don't really observe those boundaries and you can construct weird edge cases.
The time clock between the 4 different machines in your diagram, what is on the commit timestamp? How does it know, like to the milli-microsecond or whatever?
Well, getting the time synchronized is a separate task that you usually
You just depend on Unix utilities.
NTP or something for.
Yeah.
There's no time synchronization. You could perhaps do like monitoring of that, but there's no real you just rely on NTP being pretty good.
Whatever you do at the Linux level to make sure your time clocks are similar.
And there's no real strict, it's not really necessary that is super accurate, because it's just it's really just for conflict resolution that whoever has the earlier or later timestamp wins, and if your time clock is off, you always lose. That's perhaps that. But it's not terribly critical.
Some corner cases obsess on that, right? So it's not, it's like,
right.
Yeah.
So how does BDR work? Again, you have to set your PostgreSQL.com. Remember, it's all based on the write-ahead log being decoded, so you still have to have the same write-ahead log thing being set up. You load a plugin, you can turn the commit timestamp tracking on, and then there's some additional options that BDR provides to what you want to do with conflicts. You can, for example, log them into a separate table and then look at them or build some application logic around that. Then you load the extension. So there's a BDR extension, but then it uses this other extension to do for some internal management. And these are sort of, it's all implemented as stored procedures, the management interface of that. So you create a group, give it a node name, connection information, you say wait until ready. You have a second node that joins the group, says I'm node 2, this is my information, I want to join this group, wait until you're ready. And that's it, then you can replicate. Conflict handling, that's one of the sort of features that BDR really invested a lot of effort in. And you can configure that in a fair amount of detail. It's documented in quite some detail. But you can do, as I mentioned, by timestamp, so earlier or later wins. You can log to a table, so you can resolve these conflicts later somehow. Or you can write custom handlers write a function in Postgres that does something based on your application logic. So it's BDR. So if you follow Postgres releases, you will have thought that all of these first 5 ones are actually now implemented. So what we did was we kind of went out on our own and said we're going to build this BDR system, and then we're going to take all the features that initially we didn't know what we needed, right, to build this out. And then we built it out, put it out there, people are using it, and we figured out, okay, what are all these pieces that we actually built here? And then sort of split them up into chunks that we can submit to the Postgres community as features for core Postgres. So we don't have to maintain that fork. And so logical decoding was implemented in 9.4, that was a big one. Background work was implemented, and all these other ones were implemented. Global sequences, still an open problem. But what we now figured with 9.6 is that we're just going to forget about the global sequences, and we're just going to not have the fork anymore. So it's very soon, and my colleagues are working on that, and this answers your question, hopefully, is that BDR is going to be now, a major update release very soon, next couple weeks, pretty much. It's just going to be a plugin. You don't have to have a patched Postgres version anymore, and it was sort of a weird thing that the patched Postgres version was based on 9.4 beta. So there was no 9.5, first of all, and then it was also 9.4 beta 2, I think it was based on, is actually not compatible on disk with 9.4 final for some little marginal reasons. So it was sort of out on its own, right? You couldn't just switch back and forth easily. So that,
it's mostly just the global sequence.
Good, successful. Yeah, what we basically figured out is we're not going to manage global sequences in this fancy way that we envisioned. We're just going to do what basically Londiste did in the old days of just have different offsets on every node, and kind of work with that.
Update those.
It's still an open problem, and it's very difficult to really wrap your head around it, how to fix that. So global sequence is not something that is going to be resolved anytime soon, but it's an open
problem. A pragmatic, effective solution. You just
pragmatic is good, yeah. A hackish workarounds. Yeah. Yes, please. Question.
Pragmatic.
For each node, are they settable by the administrator?
The offsets for each node, are they settable? I don't actually know that, because that's still being worked on. So I know in the backend Londiste it was just hard-coded. So I don't actually know. Do you think there's a reason you want to set that, or?
Yeah, you usually run out of address space on it.
Yeah, I'll look into that. I'll forward that concern. So that's BDR again. So you can get the old one, but if you're just starting out, or you get this idea tonight, then maybe just wait a week or two more until you get a fresh new version for that. So that's has been in use for several years, and there's definitely people using that, and obviously as from 2ndQuadrant we're kind of commercially supporting that. So that's definitely working. But it is a fairly complicated system, because it has multiple masters, conflict stuff needs to be managed, and you kind of have to manage part of that yourself. And it doesn't really help you to have high availability, because all the nodes need to be connected to all the other nodes. So if one node goes down, nodes get quite upset. So it's not really built really for that. So we figured we need something that is easier to use. So we took all that knowledge that we gathered and started a new project that builds a very simple one-directional logical application system that doesn't have all this conflict stuff and all these many nodes and all these other problems. So that's pglogical that you might have heard of. So that's just a plugin, so no patches or anything. And it just does logical application from one node to another node. That's it. So that's, works from 9.4 through 9.6.
Does Replication Manager always use pglogical for 9.5, 9.6, or they're really
Rep Manager doesn't do anything with pglogical. Rep Manager is just a wraparound.
Wraparound streaming?
Around physical streaming application, yeah. And there, I don't think there's any plans to change that. It's really just a nice user interface around this old stuff. This hopefully will have a nicer user interface already right at the beginning. So this is big.
Logical replication, you don't necessarily need Rep Manager. That's more for easy to use wrapper around physical and streaming.
Right. Okay. So this is just a plugin. It looks, the main, initially I think the main really obvious use case for everyone we think is for upgrades. Because you can now upgrade between major Postgres releases seamlessly without downtime and without having to do dump restore, PG upgrade, or any of these things. You just put this plugin in, you configure it, the data appears on the other end, and when it's all synchronized, you can switch over. And then you can just tear it out if you want.
And that's 9.4 on your open.
Yeah, that's works from. You need for all of this stuff. You need 9.4 for logical decoding and some of these other things. So that's really the big threshold for logical replication in any of these solutions. But for 9.4 going forward, we suggest logical pglogical for upgrades. Or you can do other things, right? Any sort of moving data between different nodes for whatever reason. So from your transactional database to an analytics database, or maybe even some other fork of Postgres for analytics or things like that. Just move it around between your databases. Works for that. Scale out, just make lots of copies. It doesn't have any restrictions in terms of 48 or anything like that, right? Just make as many as you want. Because there are no connection paths to manage. That's what else really the big problem.
You can do like cascading, whatever.
Yeah, there's no real support for cascading per se, but you can just have the standby replicate again, because the standby is a normal Postgres database you can write to, and you can just hook it up and copy from there again. So there's no real global sort of cluster management in this. So again, we try to make it simple, right? It doesn't have this sort of global awareness of things. You can just move data, from one to the next and from here to the next, or however you want.
Go back there the way you do.
Well, yeah, and you can build a multi-master for this kind of, but it doesn't have any it doesn't have any node awareness or conflict awareness or origin tracking. So you can do copy table A from here to here and copy table B from here to here. That definitely works. If you copy table A from here to here and back, it'll probably get upset. So
when it logically comes across a physical thing in the write-ahead log that was rolled back, how does it know or figure out whether to? Does it do it and then?
How does the logical decoding deal with rollback transactions?
Yeah.
It just ignores them.
Oh, it knows by the time it.
Logical decoding works on transaction boundaries. So whereas the physical replication basically replicates rolled back transactions, even if they don't show up because they're marked as rolled back, but the data is still being copied. Whereas logical decoding just ignores the rollback transactions and
it only sees it after the commit. So it
yeah.
sees the physical
Which is
piece after
a
the
bit
commit.
of a bit of a potential drawback here in some cases. If you have really long running transactions, they're not going to be replicated until they actually commit it. So that's perhaps
it's a
one
feature
of the,
as much as a
it's
flaw.
yeah. That's sort of one of the big drawbacks that's really not easy to fix in this architecture.
It's a trade-off.
So, or you can move things around between different data centers or copy partial data. So pglogical can do all these things, right? It's just very simple table from here to there. Looks very similar to VDR. You have to have these weird settings again, load the plugin, load the extension, create a node. So this is not compatible with VDR, but it sort of modeled after that with this experience in mind. So you create a node, connection information, add tables to a replication set. Or in this case, it adds all the tables in this particular schema. So you just say replicate all these tables. And you create a subscriber node on the receiving end. And then you say make a subscription. So the terminology is provider replication set subscription. And that's it, and then it goes. And one thing we found is that one of the many advantages, perhaps, is that this is a lot faster than these traditional trigger-based replication solution. Because it's all based on the writer headlock that's already being written, and there's no additional triggers or locking or any other things going on. So it's really, it scales a lot better than using Slowly and Londiste. So this is your sort of number of clients and transactions, and the blue line here is pglogical. So as you increase the number of clients, it just runs a lot better. So we tried to submit this to core Postgres as the plugin as it sort of was written. So we wrote this plugin based on our experience, and then we submitted this as a patch to the core Postgres, saying, how about this? And then, for various reasons, people didn't like it, or didn't understand it, or didn't really know what to do with it, perhaps. So this is a screenshot from our what we call the commit fast application. So you submit the patch to what we call a commit fast, and then people criticize it, and then so it turned out there were a lot of comments about this, and one main comment was that it's weird to manage it with functions. So that was one complaint. The other complaint, perhaps, was that it still did too much stuff. So we had to go back.
These are things about BDR versus logical. I'm sorry.
Yeah, what is this slide?
This slide is just a screenshot for insiders, but that makes what we try to do is say, take pglogical. So we wrote pglogical, and you can download that as a plugin, and you can replicate away, and it works fine. And we wanted to submit that to core Postgres as the official supported logical application offering in core Postgres. So we submitted that to the patch review process, which this is a screenshot of that you don't have to necessarily understand. And this, the patch review process said, not quite. So that is why, until now, there's no logical application in core Postgres. But we keep working. So for Postgres 10, which is next year's release, hopefully, we are, in a sense, definitely.
I guarantee it. I don't know what's going to be in it yet, but it'll be called 10. It's been said.
So we're working on that now. So we took pglogical. We're doing this right now. I was working on it yesterday, and we took pglogical and stripped it down even further. What is the minimal we can submit to the community? Because if you send a huge patch to the community, people are going to be, oh, this is a lot. I don't know what to do with this. So you're going to make it as small as possible. And we're going to have it controlled by just regular sort of SQL-like commands. And so this is, I have these settings again, and I'm hoping to shrink this down even further, that you don't have to have all these settings. So yeah, this is sort of the pending functionality. This is not something you can really use, although you can download the patch that's been posted to the mailing list. So you got to reserve a couple of connection slots depending on how many standbys you want, or slaves. And then it's going to look more like that. So maybe a lot friendlier, right? We're going to call it a publication and a subscription. So on the master, you make a publication. And the publication basically just contains some tables. So I want to replicate this table, that table, or many tables or all tables. You just say like this.
Is there any kind of ANSI or ISO or any kind of thing?
No, there's no. This is just syntax we're making up.
But there is no other standard for that,
Yeah.
so that's reasonable.
Yeah, and there's been a lot of thinking going on, and actually other major, commercial SQL databases that most of you will know well by name, at least, they also use this function, this terminology mainly. So I think we think it's good.
Is that Oracle or SQL Server?
Actually, not Oracle, but all the other ones.
Everybody else uses that
kind of, yeah. Not necessarily the syntax, but they all call it sort of the same way. So we
de facto kind of.
Yeah. So we think this is, and then you on the other end you make a subscription, and you just give it a name and say, I want to subscribe to this publication on this host, and we're gonna maybe change the syntax a little bit, but this is how it looks now, and then that's it, and you're good to go. Right? It looks pretty cool. It's simple, doesn't it?
It does look good. So
that's what we're hoping to provide soon. So that's what we're working on, and we kind of hope to get this in. The release is going to be about a year from now, so it's going to take a while to actually get out. But we have this mostly ready. We hope to get it in before the end of the year, and then work out the kinks.
Make a foreign subscription to a foreign data. Optional.
So this is sort of really the smallest thing we can do to have logical replication in core Postgres, we think. And it's still going to give you all these use cases that I showed for pglogical. If you want to have a slave for scaling, you just make one. Right? Make a publication with your tables, make a subscription on the other end, data shows up. The receiving end is just a normal database. You can have temporary tables, you can do other things on it, you can aggregate things, and it's really its own database instance, except that data keeps flowing in to these tables. There's a lot of flexibility. So further things, and I kind of showed it initially, I think this is going to be the era of next couple of years where logical replication is really going to be built out. Mason, yes, question?
Yeah, regarding conflict handling, is there going to be any commit time conflict handling, or just after the fact post-commit conflict?
Question is there going to be commit time conflict handling, not in what we're currently proposing? So if we get this in quickly, and there might be some time to work something out, but the current proposal for core is really just ignore all that, no conflict handling. So conflict handling is something we got to work out, obviously. DDL handling is completely ignored. So the facilities for that exist with event triggers. And it's been done before, right? We just kind of have to wrap it into a format that the general Postgres community accepts and is useful sort of generally.
The 4 settings that you said for pglogical, those all exist, right? I looked at them.
Yeah, those settings, this is sort of basically
there's not necessarily any new.
These settings in these PostgreSQL.conf settings, they all already exist.
You can never have too many.
You just have to.
200, 300.
You just have to set them, right? And that's something that personally bothers me. We're not necessarily working on that, but that's something that
You're not creating more, so you're adding a new.
No, there's not going to be more settings really. So
at least not a lot more.
I hope not more. No. So what he's referring to is these PostgreSQL.conf settings that you need to set, and you have there's numbers of how many slots you want to reserve for different connections, and that's just bothering me that you have to do that. And I wish this were more dynamic, but it's kind of a hard thing to solve, and we really got to focus on these things. So this is sort of just way in the future, right? All these things are kind of solved in these existing products and plugins that we have. We just got to kind of shape it into a form that is kind of useful for the core product. So I'm going to move on a little bit here. So this is an entirely different track now, just to kind of give you the full picture of what scaling Postgres can do. So this was, all, this was all these previous products and features were all about replicating data from one node to another, so you can add extra nodes for performance or availability. This is a more complicated project that wants to basically give you a cluster of many nodes that appear as one database, really.
Like shared nothing, multi-master,
Sure,
kind of rack.
something, whatever you want to call it. So it kind of looks like that, right? So you have a bunch of data nodes here, and these are Postgres databases. And you could have tens of those maybe, typically. And they all get a piece of data. So this is sort of more, I mean, you can use this for anything really, but the idea is really for just giant databases. And then you have a bunch of smaller number of coordinator nodes that kind of you connect to and they know about all these guys. And then you have the guy that we mentioned at the beginning, the global transaction manager that talks to all these, so it creates a globally consistent view of the data. So all these other replication solutions, they all have, everyone has their own way of managing transactions, and then just once something is committed, it shows up at the other end. This way, you can write here and read there, and it looks like it's all one. So obviously that's a lot more complicated. So this requires a fair amount of planning ahead of time to know how you wire all these things up to it. So Postgres-XL is a fork patched version of Postgres. Similar to BDR, but BDR was sort of a small thing, and we took all the chunks and fed them back into the core Postgres. This is a much bigger change. But it kind of still looks very much like Postgres. So if you want to set this up, you set up a GTM. That's an entirely different piece of software that's included in the 12-ball, but it's a different program, right? It just initialize a data directory and then just start it up and it just runs. And you would normally set up multiple of those to have availability. And then you set up a coordinator node, and a coordinator node is essentially a Postgres database. So you make a data directory and you start it up. You just have to tell it it's a coordinator. And you make a couple of those. And you set up data nodes, again, with the normal things that you will be familiar with from Postgres. So you make a data directory, and you can say it's a data node. And so all of these would obviously go in different machines. And there's a lot of details here to be added of how all these guys connect to each other, and so there's a lot of planning really involved, and you want to automate this somehow. So this is just sort of give you an idea of how this really fits together. So then there is the SQL. Some of the SQL commands will have additional features, like clauses on it, so you can tell how you want the data to be stored in that cluster. So you just connect somewhere, and you create a table. Maybe you have a big table of users or something that's really big, and then you say, I want to distribute by round robin, and then it just goes, all the rows show up on different nodes. Yes, please, question.
Can you set a default distribution for the schema?
Yeah, there's defaults and stuff. This is just one of many options of you can distribute by hash, and by default it goes by primary key and things like that. So there's a lot of options here, right?
Because I was just curious, like if you have a schema, let's say from somewhere else, set it up on a cluster, you have to, let's say, you modify.
Yeah, if you don't put that there, something will happen by default. You don't have to always put that there. So you can just import an existing schema, and it sort of does something reasonable. So another way to do it, for example, is you can replicate every table. So the normal idea is that you have big data that you want to split up. But if you have like maybe a small lookup table, it makes maybe more sense to replicate it to all different nodes. So you can say distribute by replication, so it shows up on every node. And then one of the other key features of Postgres-XL is that it has planning knowledge that takes advantage of that. So it has a different, or a changed, advanced Postgres query planner that knows about all this distribution and does a lot of things with it. And we have one of the original developers of this in the back, and he's probably wondering what I'm talking about now.
Yeah, that guy that invented that.
So
he's quiet though. He's waiting for beers afterwards.
So Postgres-XL sort of had different names throughout time and went through different hands and companies and teams. We hired one of the lead developers of the project into 2ndQuadrant a couple of years ago, and so we're kind of steering that project now. Again, we have customers that use it. We commercially support it. It's open source. You download it. It has, that's the URL. You can download it with a tarball, and you can build it. It kind of looks like Postgres. It just has extra things. Question?
Seems somewhat similar to Greenplum. Is that?
It seems somewhat, yes. So this is one of, and there are other choices that are similar to that. Right?
This is open source.
Greenplum. There's Greenplum, or the company is now called Pivotal, but their product is called Greenplum. That is also basically a patch version of Postgres that handles big data and has sort of planner intelligence in the use of that. There's another company called Citus Data that has another product that does something like that. And so it's sort of beyond me, and it would also take too long to compare how those are different.
You like Mason best.
And Mason is back there, right?
So this
Pivotal is not here, as far as I know.
Big hickeys.
So there are alternatives for that are very different in detail. So this is open source. It looks like Postgres. You can download it and try it out yourself. It's complicated naturally because of the nature of the work. Greenplum is also now open source, but they're still on like 8.3,
Yeah.
so they're
It's from
patching it
Greenplum.
up. And they're working on it now, so this might be outdated as of today. But
And I think, to answer that better, I think this leans more towards, small transactions. It can kind of do stuff, whereas Greenplum is more towards BI. This is good for BI, but it can also be used in more OLTP type situations.
Difference, I think the main win in this is that it has planner intelligence that for multi-node awareness. If you just set this up as a lot of high availability things, that also works, but you lose performance if you just need a single node, because the global transaction management has overhead. And so it will be slower if you don't actually take advantage of that. Whereas all the other solutions, they're just, if you have pglogical or VDR, and you have a transaction that runs locally, it's just the same. It's not going to be any faster or slower than just standalone Postgres, because all the action happens sort of afterwards from the write ahead log. Whereas this needs to have awareness all the time with all the other nodes. So if you just do a transaction on one node, it's going to be a little bit slower.
But this is more than just distributed parallel query on a column-oriented database, right? This attacks the harder problems and does it.
We think so.
pretty well.
So it is a big fork, and the idea ideally would be to kind of merge all this back into Postgres as well. But this is really going to be a longer process. Yes, please. Question.
Is it possible to scale writes with this in terms of like sharding data?
Well, that's what this does, right? This is basically sharding. Yeah.
So you, assuming network is reasonably fast and the underlying block storage.
There is ideally you would have this in the same network, but there is also ways you can have multiple data centers, and there's the GTM can have a proxy so you can have multiple GTMs in different data centers, and it really goes very deep. So don't want to. I have a yes, we're almost done. Yeah.
You can do a lot of stuff.
So these are sort of the summary. These are sort of the products we're currently encouraging or supporting or asking you to check out. So we have Physical Application Web Manager is an open source tool that you can use to manage that. Postgres BDR is being updated to 9.6 as we speak and is for Multimaster with conflict handling, pglogical also for 9.6, and just simple logical application that basically works for everyone, and you can hook it up yourself in ways that you want. And as I said, we hope, and this is up to review by the community, that we want to have this built in. So it's going to be very similar to pglogical, but the interface is going to be different. And then Postgres-XL is one project that we suggest for if you want to have this MPP massively parallel kind of processing. And there's other options for that, right? We mentioned a couple of those. So they're all open source, and sort of, but they're being used in production.
Peter, is XL going to be rebased over 9.6 or maybe not till 10.0?
Yeah, the latest release, I think that was on here. The latest release is currently on 9.5, but it's going to be based. It's going to be rebased on 9.6. But that's going to take a while. That's not a matter of weeks now. That's in a month or two. I'm putting pressure on the guys now. In a month or two.
We try to keep that.
Yeah, that's
stable.
Yeah, that was actually a long time sort of gap. I think the previous one before 9.5 was 9.2, so it wasn't really being kept up to date too much in that time, but it's now sort of back in the roll, I think.
And as you mentioned, like Greenplum is, it's like 8.2 or something. It's a long time ago. Like it was based out of the.
I know Greenplum is working very heavily on merging their stuff forward, but I can't tell you where they are right now. But they were working on sort of 8.2, 8.3, 8.4.
Their
so
production stuff. So Heiki's doing some stuff in the open source stuff.
So for all those who want to know more about XL, we have a conference coming up in this very city just down the road in December. We call it SHAR16, Clustering High Availability and Replication. That's sort of sponsored by 2ndQuadrant, since we have, as you have learned, a lot of experience and interest in this topic. So that's going to be 2 days, 1 day of tutorials. It's going to be lead developer of Postgres-XL is going to be here. The main people who are working on these other replication solutions are going to be here. It's going to be tutorials. It's going to be one day of talks of on these topics and use cases and things like that. So if this 1 hour here was interesting to you and you want to learn more, you can have 1 day or 2 days of all of this in December, just down the road. So I would invite you to that. So that is the current state of scaling in Postgres. And we have used plenty of our time. So Eric, how are we with, are there any questions? We had a couple questions. So also all the questions.
We have time for just one question. So, all right, the arrow's pointed at this guy. So
I had a question about BDR,
Yeah.
which is the decision to use BDR or not orthogonal to the decision of using asynchronous replication versus synchronous replication? And if it is in fact possible to use BDR with synchronous replication, does that reduce in any way the type of conflicts that you can have, or is it the case that you can still have all the conflicts?
You can use basically all of the logical application approaches with synchronous replication that's kind of independent of what happens at the receiving end, because the synchronicity is checked by the sending host. So it's just a matter of whether the sending host acknowledges the transaction commit to its client, and so it's orthogonal, as you say, and the conflict handling is the same.
So you can still encounter conflicts even with synchronous replication?
Yeah, because there's no like global awareness of what's going on, so it's still, you know, you can have, there's no global locking or anything like that, so things can still happen independently.
Okay, Peter will be here for one-on-one questions. Feel free to come right up now and ask him. Thank you all for coming. Thank you, Peter Eisentraut.
Thank you.